Looking at now is a bit of fun and a bit of a step away from the textbook. I lie, it's not that fun. We're looking at graphs and we want to be comfy in our mind that the slope of a graph, or how steep the line is, has a meaning in real life. And so what I'm going to get us to do is graph a couple of stories, and the lines on the graph will tell the story. The first story is the story of a runner who you can barely see running from home plate on a baseball diamond around the 4 bases. And you'll see it a couple of times through, so you don't have to draw anything on the graph just yet. Oh, other than the scale. So, on your first graph, can you go up in 12s there, please? Who's having a look at the board? Alright, so we've gone up in 12s, and what we're graphing is distance from the home plate. And at time equals 0, he starts here at the home plate. And you don't have to draw anything right away. You can watch it run through, and then you're going to watch it in slow motion in a second. So, regular speed, ready, set, go. Here's that black dot. Run, 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 run. First plate. Second plate. Third. And home. Now, I don't know the dimensions of a baseball field, but the fact they've given us about 120, I would guess that second base, meaning the furthest away from home, is about 108 feet. Yeah, and let's assume he's running at the same rate. We want to draw a graph that shows where he is at each point in time over the 15 seconds, if that makes sense. So from here to 15. So he touches first base in about 4 seconds. And I won't do it just yet, but I want you guys to have a shot at graphing it. And remember, we're graphing his distance from home plate. So draw a line that you think represents him over the first 4 seconds. Alright, I'll give it a shot. 1, 2, 3, 4. I reckon 4 seconds in, he might well be 60. And that will be the map of his first 4 seconds. Let's watch him do the rest. So second base, about 7, 8 seconds. Ooh, it's hard to judge, but about 11 seconds he'll hit third. And play on. And at 15 he reaches home. Now you're probably curious to see the answer. Alright, my guess of 60 was wrong. Now, I guess the reason I'm showing you this is why the change in slope?
Because after he changes angle, although the speed is the same, he's not moving away at the same rate.
Because?
Because when it's just running to the first base, it was like directly away from the base, but when to the second, the angle changes, so it's no longer. I feel like there's something to do with trigonometry, but.
Yeah, there is some trick behind it, and we won't go into that, but you're right. In the first portion here, he's running directly away. In the second portion, there is a component that is away, but there's also a component that's back towards home. So that's why even though his speed hasn't changed, his rate at moving away from home plate decreases. So for this one here, over 3 seconds, there's 72 feet away from home. Well, 72 divided by 3, 24, means every second, 1 second across, every second he's moving 24 feet from home. So 1 second, 24 feet, which is good effort. Here though, 1 second is now much less. 1 second is what, 12 feet. So his rate of going away from home plate almost halves by turning that corner because he's coming back. Does that make sense? But the thing I'm going to stress here is how steep the line is has meaning. Yeah? Meaning that the steeper it is, the faster he's going away from home. Does that sort of get? Do you guys want to do a more challenging one? And a slightly scary one? Slightly scary one is this. This mate, definitely a math teacher, who definitely just scared all the kids off the playground. And we're going to graph the distance from the camera. So this time on your y-axis, chuck the numbers 1 to 10. Grab the second page of your notes, and there'll be graphs. Alright, and once again, you guys will see it in slow motion, and then you'll see it in faster motion. No, you'll see it in faster motion, then slow motion. Sorry. Alright, distance from the camera. Half speed. Alright. Are we happy that he's not touching the camera to start with? So at time equals to 0, he's some distance from the camera already. Add a guess, I don't know, 3, 2, whatever you want. How many feet you think he is from the camera? Alright. I'll pause when he reaches the far side of his first turn. After 2 seconds, he's as far away as he's going to be, and then he's going to come back. But note that his path wasn't a straight line to out there. In the first couple of seconds, he's not moving much further from the camera, is he? He's moving almost flat to the camera. Then he accelerates and moves much faster away at this point, and then he comes back to not moving very far from the camera. Like at this instant here, he's not getting closer to the camera and he's not getting further away. He's like moving parallel to the camera. Does that sort of make sense? So at this point, he's going fast away. At this point, he's not going fast away, but he's the furthest he can be. Which, let's assume he's like, where are we at, 2 seconds in? Oh, let's go a bit further. 1, 2, and I'm going to say you can get like 6 feet away. The reason for the shape is, at 2 seconds time, he's flat, because he's not moving towards the camera, he's not moving away.
And then it like is inverse. No, not even like whatever it's called. The like the sine wave.
Yeah, it's that. So We'll see. We'll see. All right, I'll pause again when he's closest to us. A late 3, 3.5. And by then, he's closest again. Okay, I'm exaggerating the flat bit. At this point here, where I've paused, for that instant, he's not moving towards the camera away from it, so the line is flat. And then he starts moving away again. And we'll pause when he gets to the other side. 5. Ooh. 7. Oh, an awful drawing. 8. He's back here at 10. He reaches the other side. And this is where the nice neat pattern stops, and you're just going to have your best crack. Oh, here's the answer. Yeah.